me update the stream. Alright, 17. Trick shot. You finally decode the Elvis message. Hi, the message says. You continue searching for the sleigh keys. So that big number I decoded was high. Alright, ahead of you is what appears to be a large ocean trench. Could the keys have fallen into it? You better send a probe to investigate. Ocean trench. Wikipedia as well. Oh, it does have a dock. It just doesn't stick. You have to click it every time you open it. Well, it's because I'm not logged in or anything. Cool. Probe launcher on your submarine can fire the probe with any integer velocity in the x and y. For example, let's fire straight up. Yeah, okay. Is this going to be a physics problem? Oh my. Okay. Yeah, so... Oh, we got drag. The probe's x velocity changes by 1 towards the value. So it's linear drag. Oh no, it's not linear. Whoa. Ah, okay, so it decreases by 1. Yeah, okay, so there's basically it's like if there's a fixed force against you, sort of. So it's a very simplified version of drag. It's not drag that's relative to your speed or your speed squared or anything like that. Due to gravity, the probe's y velocity decreases by 1. Okay. And so the gravitational acceleration is 1. Okay. So that's the target area. Okay. So it defines us like a square. This target area means that you need to find a velocity value such that after any step, the probe's x position is at least... After any step? Wait, so a step is... What do you mean by any step? Do they mean by that after some step it will eventually get into that region? Strange wording. The way I read it is if any step, that means every time you do a step you're in that region. But that's a step, that's a step, that's a step, so... Yeah, I would have said after some step. Am I reading this right? Well, according to the diagram, okay, we want to get to it at, like, step 7 or something. S is the probe's initial position. Okay, so that's not within, never hits the target, okay. If you're going to fire a highly scientific probe out of a super cool probe launcher, you might as well do it with style. How high can you make the probe go while still reaching the target area? Using an initial velocity of 6.9 is the best you can do, causing the probe to reach a maximum Y position of 45. Find the initial velocity that causes the probe to reach the highest Y position and still eventually be within the target area after any step. What is the highest Y position it reaches in this trajectory? Okay. Are we really just brute forcing it? I guess, is there a cap? Because couldn't you just always just shoot it higher, faster and faster in the Y direction? Any integer velocity? Really? Oh, okay. The cap is implied by the fact that the x speed, the forward speed, has to be minimum 1. So, yeah, okay, that imposes a limit because you can't just go higher and higher and higher because you'd have to reduce the x to fractional values. Okay, fine. Just turn the AC off. So I think knowing that x has to be at least 1, then we can sort of work out what like an upper bound on y, and then I suppose you can just brute force this. Shouldn't be too bad. We'll look at the numbers. We start at what, 0, 0? Yeah. And that's the region. It's not too far away, so I think this is just a brute force problem, and even if we run the simulation every time. We can shoot downwards. And we may need to. Like, maybe you can't even do it shooting upwards. Okay. Alright, so target area. Like, we don't need to parse this, but I guess I'll just do it for completeness. I mean, okay, we should really use regular expressions here. Now I have to remind myself how to do that. Nope, what am I doing? Just paste this here so I see it. I mean, yeah, we'll use regular expressions just as a reminder of how to do it. It's easy to unpack it just by knowing the indices of where the integers start and so on, but well, you'd have to separate by a comma and then by the dot dot. Yeah, we'll use regular expressions. Part 1 is a 2-line solution for Python 3 on the Reddit thread. Okay. I mean, it... Yeah, okay, I guess that's not too surprising. So it's going to be like that, but we want this. Which is going to be the plus. Is that right? Slash even going the right way? Well, okay, well, anyway, we use the online reg thingy to make sure I'm doing this right. Wait, why am I putting slashes? Wait, no, hang on, is that... Yes, that's a... Where's the cheat sheet? I need the cheat sheet. Oh yeah, of course, it's backslash. I did think I was doing this the wrong way around. So it's digit. Do we even need the brackets? Like, you just... But dot... Do we have to... We have to escape the dots. We do want this because that's how we're going to capture the groups. Alright, is that? Let me just remove this for now. Okay, okay, so far so good. Don't forget the sign. Oh, Oh, damn it. Yeah. Say in every one of these groups it could be a minus just to make it complete. So say minus question mark. Forget how regex works. 0 or 1. Alright. And I could have just hard-coded the numbers in, but that is the expression. Dot match pattern line. I don't remember what you do with this. Let me just print it and see what it looks like. Okay, G dot groups. Okay, we got it. And do we just, like, group 0 would be 150? Group 1 would be 150. Okay, got it. Right, so we'll say x1 equals, say x1, x2, y1. Is it always smaller to bigger? Yeah, should be. y2. Named my groups, yeah, that would make sense. Equals the dot groups, but we want to just int Alright, I think that will work. Okay, we did it. We read one line of input. Not sure how Python handles that. I'm sure there's something equivalent. So we just need a is in target. Give it an X and a Y. So it's less than or equal to, so can be on the... You were lurking on Wogger's stream? No, not recently, but I know that he's been doing a lot of Dynamite Heady. Code must be on some check sheet because it's been within a target area. At least 20 and at most 30. Yeah, okay, so it is on the border. So far it reads like you are converting my code to Python. Oh, yeah, I guess there is, like, really one natural way of doing this so far. return x1 is less than or equal to x, which is less than or equal to x2, and y1 is less than or equal to y is less than or equal to y2. Alright. That's given an x and a y. We should really do this. We should make a vector class, and because we were doing that a lot in the last Athens of Code I did. In fact, I can probably dig out that code and find it. Let me see. The last one was 2024. I think we were doing it quite often in this year. Just, yeah, this... Well, let's go from the end, because I probably improved it over time. Yeah, like this. Well, okay. I mean, this is as much as we need, really. Just adding and subtracting and stuff. Let's do it like that. Look at the data class. It's going to be x and y. You remember all the problems? Not really, but if I look at a problem, even from years ago, look at the description, I probably will remember most of them. And have a recollection of what I did, but I just remember that last year I was using this class a lot and writing it in a really clean way, which improved upon how I used it in previous years. Okay, so we don't even really need that until we need it. Leave it in. Oh, these x's. So if something has a position and a velocity, then we want to compute what the next step is. So define step. Oh, so hang on, this is going to be... given a pause and a vel. So the next pause will just be pause plus vel. And new vel equals the x value will be vel.x minus 1, but if it's hits 0, then we go like that. And the y value will be vel.y minus equal 1. Minus 1. Is that what they said? Yeah. That's a step. Alright, now we need a method where if we fire with a given velocity, we'll hit target, I guess, for a given velocity. This just does the whole step process, so let's say pause equals 0, 0. Velocity equals v. Let's just say while true. If is in target pause, then this is a true. We'll say if pause.x is greater than x2 or pause dot y is less than y1, then it's beyond the target and there's no way it could ever get back into the target. It's falling. If it's below, then that means it's accelerating. Welcome Quantum. Funny joke. It was also funny last stream when you did it as well. Are you gonna do some Plants vs Zombies anytime soon, Quantum? Might do it tonight. Oh, exciting. Are you still top one? No. Luke beat me. Of course he did. I mean, I was expecting that. It's a strategy game. Blue beat the game in... He submitted it to the bot. Hang on, let me check. Four hours, 36 minutes. That's pretty fast. Considering how time saves are small in magnitude, really, in that game. But, yeah, I'm second. But he doesn't have a video of it. Well, actually, I don't think he's really been using videos for any of his runs. So, nothing to learn from. Was it an offline submission? Yeah, pretty much. Here it's returned false. Rigged. At the minimum, I just want to know what plants he used. I guess he hasn't made a submission post yet, so he probably will at some point. And he'll probably say what plants he used. Pos vel equals step pos vel. Must have used the mowers. Yeah, if you tactically use the mowers, you can save time. I suppose you can tactically use garlic as well. Oh, I'm giving spoilers for Quantum. Suppose I shouldn't. Quantum, don't use mowers or garlic. You're now banned from using mowers or garlic. Got 100% on Die Hard 3. No one saves New York. I was so close to beating him in Pokemon. I'm gutted about that. Like, I was just minutes away from not only beating him, but having a much better score. But I just didn't finish within time. Because he had 6 losses, and I had 3. But I just didn't finish. I think I finished at like just 10 minutes overtime. Although I was like, as soon as the 5-hour mark had gone, I was not even trying. So I reckon realistically, I would have, if I was still trying, I probably would have finished about 1 hour 5 minutes. Quantum, will you join all the races next time too? What the struggle are races? Everyone's gonna want a rematch. I mean, look how close that Portal game was. Kramit's definitely gonna want a rematch there. Like the thing of Mara's talking about the struggle races. Alright, so that's everything in place. Now we just need a strategy for... so the X is obviously capped by, like... the boundary of the area. So like we don't want velocity x to be any higher than that. The y is the one I'm not completely sure about. Okay, so the target area is definitely below us. Okay, so we want the y to be as high as possible, so the minimum y will obviously be like minus 129. The maximum y would be what? Um, it's not entirely obvious to me what the maximum y would be. Like some bound on it. Hang on, have I got this? Have I got this X drag done correctly? Let me look at that again. Interesting. They say the x. They also point out that the x velocity, if it's negative, increases by 1. In this part 1, I don't see any reason we would ever shoot it with a negative velocity, so we won't worry about that for now. I should probably code it correctly. Just in case, because I'm bound to forget about it. Won't be all over it this time. Oh, okay. How many wins did you get, Quantum? You won Achilles, I think. Did you? And the the really unexpected one was Resident Evil against Garlips, who is a Resident Evil speedrunner. That's the correct drag now. So I would think we just do this for x in range. Sorry. For vx in range, there's got to be minimum 1 and maximum 2. Yeah, if we did x2 plus 1, that would put us past the target. So yeah, we'd be doing that. For vy in range, so the absolute minimum it could be would be y1. Uh-huh. We just go for 1,000 or something. I can't think what the cap is right now. If will hit target. Let me just see. Well, this is not the answer, but let's just see what we get. Attribute I. Oops. Okay, so that's 1,000's too big. Wait. Yeah, 1,000's too big. We're getting values though. That's everything in range 1,000. Okay. I wouldn't join a heady race, sorry. Maneuvered it. I didn't stop you from joining a portal race. But, to be fair, Kramit and you had, like, I guess the same amount of playtime at Portal anyway. Like, Kramit hadn't really studied the game intently. He probably played it a couple of times, and you played it once. So, yeah, I guess you were both the same level anyway. Alright, what am I doing with this? Oh, we need to find the highest Y value. So the highest Y value is going to be when Vy is 0. When its Y velocity is 0 and it's like at a peak. But now I'll just print it. I can't be bothered to unpack the values. Let's say, oh, okay, we can do this. We can say max. Oh no. We'll have to return 2 values here. Okay, so we keep the maximum Y value attained, and then we'll return that. Return. Wait, so Quantum, you said there was going to be a stream at like 6 p.m. today. Is that the Plants vs. Zombies stream, or is there another stream? So we return the max y in either case. My will probe hit method returns a tuple of success and max height. I see, yeah. Okay. Alright, let's just see if this is right. I don't know if there's higher values of y which would yield better results. You don't even really need to do it this way. Like if you knew the because it's linear. It's just solving a quadratic equation. If you know the initial velocity, you can immediately in one step calculate what the maximum height is. So you don't actually need to use this step thing, but whatever. Alright, just let it run. $8256. So I'm not sure about this cap, whether this is even high enough. Maybe there's higher values that am I actually gonna have to do some maths here. Okay, that's correct. Let me have a quick think about that. Okay, just realized that you don't need to, like, if you knew the x, you would know if the hang on. No, I forget what I just said. Can I share the weird solution? Doesn't seem to work for part 2 anyway. Yeah, sure, you can share it. Oh, you're talking about the the Reddit one. Yes. Find all. Okay, so that's just the regex print y min plus 1 times y min 2. So it's solving a quadratic equation. Wait, y min plus 1 plus y min divided by 2. Wait, okay. Oh, so it's not printing the, Oh, it is printing the answer to part 1. Oh, I see. It's based on triangle number sequence. Oh yeah, I get that it's the yeah, okay. Yeah. That's interesting. Like, for it to end up in the target region, you also need you can look at X and Y independently, and you can say X has to end up in target X, if you're projecting onto, like, projecting everything onto the X-axis. The X velocity, in one dimension, the X velocity would have to end up in the target region, and same for the Y. So you can look at those independently, and that would, I guess, you can sort of work out that there's a pattern there. Well, of course, they have to arrive at the same time, though, so it's not, you don't actually, that's not completely independent. Alright, so, what is part 2 then? Maybe a fancy trick shot isn't the best idea. After all, you only have one probe, so you had better not miss. To get the best idea of what your options are for launching the probe, you need to find every initial velocity that causes the probe to eventually be within the target area after any step. How many distinct initial velocity values cause the probe to be within the target area after any step? So, I mean, we have everything in place, don't we? Unless the cap isn't even the right cap. So we say, okay, so part 1. Part 2. Is it not just this? Two, 3, 2, 6. Hello, Fast Mama Jama. This looks really deep. I got a script to catch drones in my channel. Written Python, but it mostly catches birds. Catch drones? Like... What do you mean by catch? Like physical drones? Like... But, like, is this an image recognition thing? Like, to recognize if something is a drone or a bird? Ah, okay. That's cool. So you're not actually physically catching them, I guess. That would probably be illegal if, I don't know, if they were endangered birds that get caught or something. Would need lasers. Do you get a lot of drones flying over your house? Oh, okay, let's test this result. Okay, That's correct. That thing about the triangular numbers is interesting. I can't be bothered to do the maths right now, but maybe offline I'll just look at the numbers again and maybe realize the pattern. But I guess for part 2 you do kind of just need to brute force it, don't you? You need to find every value. I mean, you can range over the target area instead, and for every value in the target area, then you can kind of work out exactly what the x would need to be to arrive there, and that's a triangular number, of course, because it's going to be cut off. Well, it's not necessarily a triangular number. It's like the first part of a triangular number. It's like 4 plus 3 plus 2 plus... Like, it would be something like 3 plus 4 plus 5, maybe, but it won't go down to 0, necessarily. Oh, no, but it will go down to 0 eventually after it leaves the target area. Okay, so that's why the initial... Okay, that's why the initial velocity x is a triangular number. I see. And same for the y. I'm trying to find alien life. Metallic orbs. OpenCV has round shape detection. Works great with the sky too. Interesting, but... how do you recognize... So you're trying to recognize things that don't match in a thing we are familiar with? Since I guess we don't have any actual alien life data to work with. So it's like just something that recognizes that something doesn't look like something we know? Is that... But you say metallic orbs, so have you seen any metallic orbs? I use hard datasets of UFOs from only real UFOs. There's datasets of UFOs? Okay. Oh, I mean, that doesn't surprise me. I guess, of course, there are. Interesting. So, did you find any metallic orbs over your house? Boogosphere was caught recently. What is that? Found a shorter part 1 solution. How does the solution not involve Y max? Are they just guessing? Like, you could... Like, if Y max... If it was really narrow in height, would that solution not work? And it just happens to be that the target area is wide enough that it doesn't matter? Or... Like, surely that solution wouldn't work if it just happened to... If it was like a 1 width, 1 height target area. Then you'd have to... I think that solution might rely on the data provider in not all cases. Yeah, it must be. Yeah, you need to use Y max in the general case, but it might be that the nature of the data is just generous. The Buga sphere is being analyzed now by the University of Mexico. It is likely an anti-gravity time capsule. What? Okay. I don't know anything about that. I don't know what an anti-gravity time capsule is. Is that something that doesn't obey the laws of gravity? It just floats? It can likely travel time. Space. But when you say likely, like, why would it be likely? Just because it's an orb that flies? Surely... They have not opened the bugger Okay. But then how can they draw any conclusion about it like being likely to travel time and space then? I don't really understand. Like, by all principles of physics, surely it's incredibly unlikely. Alright, I don't know if I have time to take a sneak peek at this. Snailfish. Fish. I remember this. Have we dealt with snailfish in another year? Oh, it's another... Okay, it's some kind of game of life-y type thingy. I remember... I'm sure there must have been a problem before with involving snailfish. Maybe it was like a throwback, like in one of the later years. Yeah. Is it just adding all the numbers? I'm not really looking in depth, but... I mean, you are ultimately adding up the list of snailfish numbers, I suppose. That's what it's asking for. But I don't know how exactly it's unpacked. And I shouldn't really look too into it. This is spoilers. We'll deal with this next time. Alright, getting there. Let's see again if anyone's actually doing anything remotely like Advent of Code. Step away and you finish it, yeah. I mean, part 2, just, we had it all done already. It was just count the successes. Alright. This was mine, very similar. Accessibility? Appearance? Okay, here we go. Dark colorblind. Let's go with dark colorblind, see if that... I normally would use 4. We could try that. Alright, there we go. So yeah, on that note about that Reddit solution, I guess I mean, I wouldn't have done it that way because, yeah, it was relying on the data being nice, but I think you do have to simulate it to some extent for the solution to be completely correct. Um, yeah. But by all means, you can look through triangular numbers because that will cut down the number of things you check, certainly. Yeah, I can see that's what you're doing. If you're interested in catching UFO, you can get script free. I've never had any motivation to catch UFOs, but maybe I'll take a look at your code afterwards. But when I was living at that island that we were talking about before, I did get a lot of drones flying. I think people were testing their drones there because it was just a good place to test drones, like a remote island where no one cares. Probably wasn't legal. Actually, now that I think about it, it wasn't far from an airport, so that's probably. Well, there was probably a height limit because they did allow there were legal drone uses for parties and stuff, so I guess it was allowed. It's just as long as you don't go near the airport, that's a big no-no. I think it would be even you could even be the death penalty if you fly it near the airport. Thailand's pretty strict about that. They have death penalty for people using those Chinese lanterns near the airport, and people do it. It's really stupid. Um, People release those lanterns near the airport. I don't think anyone has actually been executed for it, but they would get pretty bad penalty for doing it. They catch superheroes. What do you think is more common, alien UFOs or superheroes? About the same. At least with superheroes, they usually look like normal humans. So we have data on that for image processing. Oh, alien superheroes. Oh, that's interesting. Alright, that's cool. Not much is appearing on this map. I guess it's just like an outline. Oh, of a cave system that we're going through in a submarine. Wonder if there's any problem which could be solved using Subnautica. Probably not, but there are problems people solve with Minecraft or Factorio or there was one that was just about like placing blocks, and so someone used a physics engine in a game to actually do that. Okay. That's it. Um, Probably we'll be back tomorrow. Yeah, that's it. So thanks for stopping by. And see you next time.